So here is another question on Coulomb's law, electric charge and Coulomb's law. So the question is that a charge Q is to be divided in between two objects. What should be the values of the charges so that the force between these objects, these two objects, is maximum? Okay, so this is the question. So if we try to break it down, what it actually says is that we have a total charge Q, okay, total charge Q, net charge, and it has to be divided in between two objects. Let's say these two objects are this, okay, charge, let's say the object A and B, let's call them. They are separated by a certain distance, let's say it is R. Okay, so how this charge can be divided, how much charge, how much portion of this charge will be given to A, how much should be given to B, so that the electrostatic force between these two objects will be maximum. Okay, so let's say from this total charge capital Q, small q amount of charge is given to A, small q. Remaining charge is Q, capital Q minus small q, this much. Okay, these two charges, small q amount is from Q is given to A, remaining is given to B. This is how the charge is divided. Now the force, the electrostatic force between object A and B as per Coulomb's law is 1 by 4 pi epsilon 0 Qa Qb by R square, which is equal to 1 by 4 pi epsilon 0 small q multiplied with capital Q minus small q by R square. Now force will be maximum when the derivative of this force, the electrostatic force with respect to charge, is equal to 0. This is the condition. This is the condition for maximum force, electrostatic force. So here we have to take the derivative of this expression. So d by dq of 1 by 4 pi epsilon 0 q into q minus q by R square. Here 1 by 4 pi epsilon 0 and R square, they are constants, so they will come outside. 1 by 4 pi epsilon 0 R square, that is equal to 0. d by dq of q minus q square, okay, capital Q multiplied with small q minus small q whole square, that is equal to 0. That implies d by dq of qq minus q square is equal to 0. When this much goes to the right hand side, gets multiplied with 0. That implies q minus 2q is equal to 0 when we take derivative. Okay, with respect to small q it is, okay, it is all with respect to small q. That implies q is equal to 2q or q is equal to q by 2. So this much is the value. So the charge given to A is equal to q by 2 okay, half of the original total charge, and the remaining half, q minus q by 2, which is equal to q by 2, is given to B. So when the charges are equally divided, equal amounts is given to both A and B, the electrostatic force of between the two objects will be maximum. Okay. Hello friends, so here we are with another question on electric charges and Coulomb's law. So here the question is that two identical spheres having opposite sign, they attract each other with a force of 0.108 Newton, okay, and the separation distance is 0.5 meter, okay. The spheres are then connected by a conducting wire, which is then removed, okay. First it is connected, then it is removed, and thereafter those two spheres separated by the same distance of 0.5 meter, they repel each other with the force of 0.036 Newton. First it was attracting, now they are repelling each other. What were the initial charges on the spheres? Okay, so this is the question. Now let us try to understand it. So first we have two identical spheres. Identical spheres means their radius is the same, the dimension is the same. Let's say we have spheres 1 and sphere 2 of same dimensions, radius. They are separated by 0.5 meter always. They have opposite sign, opposite charges. Let's say sphere 1 carries a charge of plus q1 and sphere 2 carries a charge of minus q2. So obviously here, as there are opposite sign, opposite charges, they will attract each other, okay. There will be a force of attraction. That force of attraction is equal to 0.108 Newton, okay. So here we know that any kind of electric force, whether it is attraction or repulsion, that is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. So if we substitute the values here, that is equal to 0.108 Newton, that is equal to 9 into 10 to the power 9, substituting for 1 by 4 pi epsilon 0 into q1 and q2, okay. Here I am not taking the sign minus q2, I am just taking the magnitude, I am only considering the magnitude, q1 q2 by 0.5 whole square. Force of attraction means they are of opposite sign, okay. So that implies, if we try to find the value of this product of the charges q1 q2, that will be equal to 0.108 into 0.5 whole square by 9 into 10 to the power 9. So if we calculate it, it is coming around 3 into 10 to the power minus 12. 3 into 10 to the power minus 12. So that is very important. Let us write it down here. Q1 Q2 is equal to 3 into 10 to the power minus 12. Okay, this, the product of these two equal and opposite charges. So what happened then, these two charges Q1 and Q2 minus Q2, they are connected by a wire, plus Q1 minus Q2. So as these two spheres, they are of the same radius, okay, they are identical in dimensions, so they will share the charge equally. So the net charge after being connected by wire is Q1 plus minus Q2, which is equal to Q1 minus Q2, the total charge after being connected through the wire. So now the charge on each sphere will be, as the total charge will be shared equally, it will be Q1 minus Q2 by 2 charge on each sphere. So now when the wire is removed, each sphere, identical sphere, is left with charge Q1 minus Q2 by 2. Here also it is Q1 minus Q2 by 2. Separation distance is the same, 0.5 meter. But now, because of equal charges, equal magnitude, now they are repelling each other. Instead of attracting each other, now they are repelling. Okay, here force of repulsion is there. Now that force of repulsion is equal to 0.036 Newton. Okay, again that is equal to 1 by 4 pi epsilon 0. So if we will directly substitute it with 9 into 10 to the power 9, no need to do that 1 by 4 pi epsilon 0. So it is 9 into 10 to the power 9 Q1 minus Q2 by 2 whole square, because both the charges they are the same, Q1 minus Q2 by 2 whole square, by R square, which is again 0.5 whole square. Okay, separation distance is the same, 0.5 whole square. Okay, this. So now we have to determine the value of Q1 minus Q2. So by bringing it to the other side, Q1 minus Q2 whole square, it will be equal to 0.5 square into 0.036, that is this Newton, and this Q1 minus Q2 by 4, this denominator 4, that will also go to the other side, by into 4 by 9 into 10 to the power 9. So that is equal to, let us calculate, 4 into 10 to the power minus 12. 4 into 10 to the power minus 12, that implies Q1 minus Q2 will be equal to root over of this 2 into 10 to the power minus 6. Yes, 2 into 10 to the power minus 6. This is also very important. So we have Q1 minus Q2 equals to 2 into 10 to the power minus 6, and Q1 Q2 is equal to 3 into 10 to the power minus 12. This much data we have calculated. Now Q1 plus Q2 whole square, A plus B whole square, is equal to Q1 minus Q2 whole square, that is A minus B whole square, plus 4 Q1 Q2, 4AB. Okay, this much. So we'll substitute this value and this value in this equation. Okay, so Q1 plus Q2 whole square will be Q1 plus Q2 whole square will be Q1 minus Q2 whole square, that is 2 into 10 to the power minus 6 whole square plus 4 into 3 into 10 to the power minus 12. That is equal to 16 into 10 to the power minus 12. It will be 16 into 10 to the power minus 12. Okay, that is equal to Q1 plus Q2 whole square. Now root over of that will be equal to Q1 plus Q2, that is equal to 4 into 10 to the power minus 6. Q1 plus Q2, 4 into 10 to the power minus 6. This is the final equation that we want. Equation, let's say this is 4. So if we notice equation 2 and equation 4, Q1 minus Q2 is 2 into 10 to the power minus 6. Q1 plus Q2 is 4 into 10 to the power minus 6. By adding equations 2 and 4, we get 2Q1 is equal to 6 into 10 to the power minus 6. That implies Q1 is 3 into 10 to the power minus 6. We have got Q1. So that implies Q2 is 1 into 10 to the power minus 6, or simply 10 to the power minus 6 coulombs. This. Okay, so we have got the result, the initial charge on these two spheres. But in this case, Q2 will be negative because it has been asked that, or it has been mentioned in the question that they are of opposite sign. So we have taken plus Q1 minus Q2. If you would have taken minus Q1 plus Q2, that would have been also correct. But here we are only concerned with the magnitude. Okay, we are only concerned with the magnitude, not the sign. That's why deliberately I did not include the sign here, because we are only concerned with the magnitude of the charges. It does not matter which charge is which one. They are of opposite sign means the magnitude of the other charge should be opposite to the first one. If this is negative, it will be positive. If this is positive, it will be negative. Okay, as here we have considered plus Q1 minus Q2, Q2 will be minus 10 to the power minus 6 coulomb. Okay, so here is another question on electric charge and Coulomb's law. Okay, so friends, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.